Okay, so we'll go over the 2D arrays now, trying to do it in slightly a different way, so you can have several potential methods for creating your arrays for your assignments. So in the last video, we went over the 1D array, and we started with constructing a domain and a range to be able to create our points. This time, instead of doing that, we'll make a series. So a series works in a similar way to the range, but instead of creating a domain, you have a start number, you have the step size, and you have the number of points you want to make. So I'm going to start with 0, I'm going to step 1, and I'm going to make 50 points. So you can see here, it starts at 0, we go to 49. And I'm going to copy that because I'm going to make a series for the X and a series for the Y. Now, as I mentioned in the earlier video that talked about data management, if I were to plug this in to make a point, where this is the X and this is a Y, you can see that it takes the first number 0 for the X, the first number 0 for the Y, and it makes a 0, 0. Second number 1, second number 1, makes a point at 1, 1. And so it doesn't make a 2D plane as much as just a linear array along that line. That's not exactly what we want. So in the previous video, I mentioned a tool called cross-reference. What that is take each point from each list, and instead of having 50 X's and 50 Y's, we now have 2,500 X's and 2,500 Y's. So this allows us to then have for each X all the Y's, for each for each X all the Y's, and for each Y all the X's, so that we have the right number of points that we need. So right now we don't have anything set for the Z value. So we'll use, instead of using the evaluate command like we did before, we will use an expression. So this is very similar. You feed in an X and a Y to the expression, and you change the value or the expression that you want per your math equation. So I already have the math equation that we did in the class. I'm going to plug it in here. Looks complicated, but it's just playing around with different math values and equations to get some kind of surface. So here you have an array of 2D array of points that we give a Z value, so that it sort of makes this undulating surface. So if we wanted to make that physically a surface, we would say surface from points, plug in the points of the array, and it wants to know the number of points in the U direction. So we can just use this 50. The U direction is actually the X direction in this case. So it'll make a matching surface for that. For the array, though, we'll do some things slightly different. We're going to make geometry that's on these points, and to do so, we need to make planes so the geometry knows at what orientation we want it. So I'm going to make a plane. Or plane normal. We use these points as the origins of the plane, so that goes into O for origin of the plane. And then for the z, instead of being the z of the file, I'm going to use those points again. So what this does is basically makes a vector from this center point to each one of these points, and I can display that. If, for instance, I use a vector display, and I can say, okay, the starting point of each one of these vectors, the base point, is going to be the xy plane, and I put these on there. What you end up seeing is a bunch of arrows that all point to each one of these, and those are going to be the z direction of these planes. Okay. And so from here, what I want to do, so this makes kind of see concentric planes sort of all oriented to the origin. So I want to change those slightly. I want to rotate them by some numerical value and across different axes. So I can say rotate, I'm going to rotate these planes three-dimensional, rotate 3D. You can see what this is already starting to rotate along some axis. I'm going to rotate it around the unit x, so the x direction of the file, which starts to do that. And then I'm going to rotate each plane. Instead of rotating around the origin, I want to rotate it around the point. So that's going to be the center point of rotation. So now they're all individually rotating around the origin of that plane. And then for the angle that I'm going to rotate it, I don't want to rotate it in radians because that's maybe not as common as degrees, or at least not as easy to understand. So I'm going to switch that to degrees, and then I'm going to make up an equation to rotate that. So I can say multiplication, maybe I use this z value, multiply it by 180, and then I will divide by pi. This is kind of random. I'm just picking, some multiplication, some division, using numbers like pi or a slider so that I can start to adjust these. And then I'll plug this in to the A. So I'm going to hide all the other stuff. You see now what was kind of a smooth surface, because I'm rotating all of those planes, I can get kind of more complex surface patterning happening from those rotations, which looks pretty interesting to me, so I'm gonna go with that. So I have here, I'm gonna organize these a little bit. I'm gonna say this is my array, create array. And this is what you guys will do in your file to sort of organize these as well. This is going to be making the plane and rotating the plane. It's going to be a little more legible. And then I'm going to create a plane off of that, a planar surface off of that. And so what that needs is a plane, which we have already. You can see that makes giant planes, which is not exactly what I want. Looks kind of interesting, but it's doing something a little crazy. So I'm going to instead take this x and y, which are really domain values, -10 to +10 for both x and y. I'm going to put something much smaller. Make a new domain. construct a new domain. And I'm going to go from negative 0.5, I can make this negative, to positive 0.5 to use as the domain for both the x and y. So that makes much smaller surfaces. If I hide these, you can see that these surfaces are now built along those planes. Select these and add them to the group as well. So this is create surfs. Okay, and then one last thing that I want to do with this is give it some variation in color. And so right now, they're all the same color. And I can give it a new color, adding a custom, custom preview. So this will take this geometry and add some material to it. You can see the default is pink, but we want to add new color values for each plane. So what can we use for that? We can set that in reference to the z values. So as the z increases, the color changes. So let's do that. We have some value coming from the z. I'll scoot down here so we can see it a little easier. And I can do several things. So I can see what those values are. 2, 6, all kinds of things. Let's see what the bounds are of these numbers. So from 2 to 24. Okay, if I want to make a color, I can use hue, saturation, lightness, I think it is. And what that allows me to do is it sets all the color ranges from 0 to 1 along a scale. So I'll go ahead and I'll plug this in to the hue. I'll plug this into that. And you can see, okay, we get a bunch of crazy colors all over the place. And because this is not between 0 and 1, but between 2 and 24, it's sort of going through those color ranges over and over and over again. So we want to scale that down so it's more of a gradient across that surface. So we can do that in a number of ways. We can just divide that number, say by 20. That gets, instead of bounded between 2 and 24, it gets it closer to between 0 and 1. And we could tweak these if we wanted to actually be between 0 and 1. Make that gradient more specific. We could also remap. This is the way I did it in class, to say these original numbers were between 2 and 24. So if I plug these numbers into the remap component, it'll take a range of numbers with a specific domain and remap them to a new domain. So what was originally 2.4 to 24 will become 0 to 1, and each number in between that will kind of maintain its relationship to the other numbers, just scaling that whole thing down. So I'm going to plug in the domain of that set. So it's going to scale these numbers that are in this domain to a new domain. If I plug that in, you can see it changes it slightly, but this 2.4, which is this lowest one right here, is going to be at one end of the spectrum, and probably this one over here, or maybe over there, is the 24, which got scaled down to 1. And that's going to be at the upper end of the spectrum. So, so now all these numbers are between 0 and 1. There's one other thing that I want to show you in terms of color. And that is, let me organize these real quick. And that is a graph mapper. That's one thing that I don't think we've seen yet. What that does is it makes a graph, and we can set specific graph styles, a Bezier graph, kind of graph, Gaussian curvature. These are just the general shape of the graphs that are going to come out of this. This is a Bezier curve, and it's just a standard straight line right now. And if I plug these values into it, what's between 0 and 1 going into it will stay between 0 and 1, but their relationships can be skewed. So right now I have the same numbers. As I start to adjust these, you can see that that relationship slightly changes. And to make that more visual, I'll plug this in here, and you can see I'm basically adjusting that scale value of the colors to make it more weighted to, say, the blues, or more weighted to the yellows and oranges, depending on which way I pull these. So I have a little more control over the specifics of that color range.